We may already be holding the secret to evolution 4.0. 3D printing is an additive manufacturing technique widely used in architecture, engineering, and education. The process was simple, making it a good choice for manufacturing intricate pieces and components.
Numerous studies have demonstrated the advantage of 3D printing. Whatever the case, there is a significant issue with the printing filament substance and its waste. Some of the polymer filaments used in 3D printing are not biodegradable and may pose a risk to the ecosystem. Some of them are biodegradable and kind to the environment. For example, polylactic acid.
Polylactic acid, also known as PLA, is a thermoplastic monomer derived from renewable organic sources such as cornstarch or sugarcane. Some of the properties of PLA are low melting point, high strength, low thermal expansion, good layer adhesion, and high heat resistance when annealed. Despite its unique properties, PLA took about 12 weeks to biodegrade, which slow degradation leads to an increased rate of plastic pollution in the environment. Our objective is to increase the rate of biodegradation and lessen the plastical impact towards the environment. Come with me.
We did some tests on PLA and soil analysis that were subjected to different incubation times at two different temperatures, which are 25 degrees Celsius and 50 degrees Celsius. The first one is the weight loss and biodegradability test. We start by preparing two different containers containing particulate soil. Then we bury the washed and labeled PLA in a sheet of coupons in the soil before we subjected the samples to two different incubation temperatures of 25 degrees Celsius and 50 degrees Celsius. And based on the labels of the coupons will be regularly be taken out and recovered from the soil according to the set of incubation times. The soil where the coupons are being placed also is sampled for the soil analysis.
For the results, based on the wet loss analysis, wet loss has achieved up to 10.36% and 1.36% for 50 degrees Celsius and room temperature, respectively, after 65 days, which indicates that degradation has taken place on PLA by soil. However, higher temperature leading to more polymer chains has been disintegrated by applying more kinetic energy to the PLA molecular chains as compared to room temperature, where kinetic energy was very slow. For physical analysis, it can be seen that after 65 days, the buried PLA at 50 degrees Celsius had become brittle and physically disintegrated as compared to incubation at 25 degrees Celsius, which hypothetically has no degradation occurred within the testing period.
As for chemical analysis, based on FTIR analysis, the existence of certain peaks as shown indicate that the degraded PLA at 50 degrees Celsius for both day 1 and day 65 have portrayed a significant effect on the functional groups of the degraded PLA as compared to the PLA incubated at room temperature. Prolonged degradation time has also increased the peak intensity of these peaks. The second FTIR analysis shows the absence of these certain peaks. It indicated that a reaction has taken place where PLA has removed the CH bond after undergoing biodegradation in soil. Meanwhile, these peaks exist after biodegradation of PLA in soil, and these peak intensities have increased when higher temperature of the biodegradation process have taken place. For soil analysis, we obtained that the water holding capacity and initial moisture content of the soil were 59.1% and 29.3% respectively. The initial pH of the soil was determined as 4.34 respectively. pH values of the soil taken together with the PLA sample buried at 50 degrees Celsius were summarized in Table 1, and it is demonstrated that in prolonged incubation time, the pH of the soil increased from 4.34 to 6.78.
Before the time runs out, let me conclude our study. First, the biodegradation of PLA increased by 10% when the temperature was raised to 50 degrees Celsius. Therefore, the higher the temperature, the faster the biodegradation of PLA. Second, the pH of the soil neutralizes as more PLA waste degrades, meaning that the biodegradation of PLA won't have a negative impact on Earth's soil. Last but not least, the biodegradation of PLA under high temperatures would help to solve the abundance of microplastic pollution on the Earth, especially those that come from industrial activities such as 3D printing industry.
In the near future, the results from our study can be implemented not only for better PLA waste management, but also for further studies of other industrial materials, thus contributing for a better future. I'm NAQIB.
And I'm Adlina.
And I'm Amir. That's all from us.